A mass capillum is hanging by a string. So let this be a string, and let this be capillum. Let this be capillum, and a bullet of mass small m. Let this be small m. So after the collision, this mass capillum is raised by a height of h. So this is the position. So after collision, let this be the position. Such that the distance between these two particles, these 2 points, is h. This is h. This is h. So after the collision, the bullet is actually embedded in the mass capillum. So mass of this body will be m plus capillum. So we have, by applying conservation of linear momentum, we have m into v equals to m plus capillum into v dash, as this is perfectly inelastic collision, and if the velocity of bullet is v before collision, we can write this equation. So just after collision, v dash equals to mv by m plus capillum, and from now, by applying conservation of energy, we can write m plus capillum into g into h equals to half times m plus capillum into v dash square. So this is conservation of energy. So by this we can write 2gh, root over 2gh is equals to v dash. But we have v dash as mv by m plus capillum, which is equals to root over 2gh. So we have v equals to m plus capillum by m into root over 2gh. So this is the velocity of bullet before hitting the block of mass capillum, so that the combined system goes to a height h after the collision.